Hello everyone, welcome at this session on best practices of implementing intelligent edge solutions with Azure IoT and AI. My name is Michiel Mateev. I'm Microsoft Regional Director Program Member and also Microsoft MVP for Microsoft Azure and Data Platform, community enthusiast, blogger, consultant, and solution architect on Azure and data platform solutions from many years. I have PhD on cloud computing, and if you would like to learn more about topics where I contribute, you can follow my blog and follow me in social networks. In this presentation, we will cover several topics. What exactly is edge computing? What is AI edge, IoT edge? We will have overview and introduction on these topics. We will talk about Azure IoT Edge architecture as overview, and we'll go into some details. We will follow also some best practices explaining what is possible to have with Azure IoT Edge for Edge AI solutions. And at the end, we will have several demos. Let's now see what exactly is IoT Edge and how we can get advantage from this technology. IoT Edge is related to IoT solutions, and IoT is one of the fast-growing areas from technology sector where in exponential order devices connected to the cloud solutions are growing each next year. IoT solutions are available in almost all business domains. You can see IoT solutions in energy area, in automotive, in healthcare, smart cities, smart homes, agriculture, and many different areas. Nowadays, almost each business domain is related more or less to IoT solutions. It is interesting to understand what is the connection about edge computing and IoT, or exactly what is IoT edge and how it is related to AI edge. So edge computing, like concept, is starting from 90s with content delivery network approach, where static content is delivered in different locations to many edge servers to be possible to distribute faster and more reliable to consumers this static content for different purposes. Later, peer-to-peer solutions stay popular, and it is also one possible format of edge computing where it is a balance between computing, which is in exactly location, plus many other computing resources which are available in different locations and which can be used for different type of analysis. From 2006, cloud computing stay more popular and fast growing, and more solutions are stay related to cloud services, which provides different analytics capabilities for different solutions. Cloud computing is very useful when you need to have elasticity of your analytics resources and to be possible to relocate for different purposes dynamically different computing resources. The case with cloud computing is that analytics resources are not close to the place where information is generated, and for different type of analysis this information should be transported to different places in data centers worldwide. It is something which is related from one side to additional expenses regarding to data transfer, and also it is related to some latency because of physical limitation of transfer to long distance. Because of this, later fog computing is appeared. That means we have additional computing resources like network, which is close to the place where data is generated. And we have from one side analytic capabilities in the cloud, but we have also some resources close to sensors which generate data. It is something which is pretty close to the modern concept of edge computing. Nowadays, edge computing usually offers pretty smart and balanced solution where you have analytics capabilities uh, on site where we have sensors or very close to sensors, and additionally we are using also cloud resources. Regarding to different cases and implemented logic, these analytic functionalities can be balanced between edge computing and cloud computing. This is the main and most popular solution nowadays when we talk about edge solutions. Usually, edge computing is never only on the edge. It is related to part of solutions where we have together analytics resources in the cloud and resources which we are using close to sensors where information is generated. Let's now go a little bit deeper into edge concept. We can assume that edge computing is a form of distributed computing where some resources are copied from remote location to local one. As we discussed, usually edge computing is just part of modern solutions, and we have dynamic and smart balance between analytics on the edge and analytics on the cloud. There are several huge advantages using edge computing because now we still have limitations regarding to network technology. These big advantages are mostly related to privacy, latency, and reliability. Privacy because quite often information should not go outside of specific area or location. It is related to different purposes, regulations, some common understanding about human privacy and principles, and it is something which is very important for modern solutions. Sometimes analysis need to be provided very fast, and latency is not acceptable to have immediate response regarding to specific input time series. Reliability is another point. Reliability usually is related to availability of internet connection and availability of remote services. It is important for many areas and many solutions to have these analytics functionalities available always when it is needed. And distributed systems quite often cannot offer such high SLA to say that this reliability is very high and we can rely on SLA for this solution always. Let's now see a high-level overview of edge computing. We have different devices. These devices are connected to local nodes. That means computing resources very close to these devices. We have analytics capabilities, that means computing, which is possible to provide different kind of data transformation and business logic. We have storage to be possible to persist this data for more or less, and additionally we have cloud resources where we have separate storage and analytics. The good part of cloud computing is that we have almost unlimited analytics resources. That means you can scale your computing and your storage regarding to your needs. When you are using edge computing, of course, these resources have some limits. Let's now see the high-level design of IoT solutions. We have different sensors or some kind of managed objects, devices which generate data, and these devices are communicate to the back-end services via IoT gateways. IoT gateway, we name a component which establish internet connection, and it is a gateway between all devices connected to this gateway and backend services which are able to provide additional computing resources. Usually IoT solutions generate data and via IoT gateways send this telemetry data to IoT back office. In the backend services, we have different analyses which are used for different purposes, monitoring, tracking of device state, also different kind of analysis regarding to predictive analytics. If it is needed, it is possible to have communication in the opposite direction, backend services to notify devices for some specific uh, purpose. It is possible also to send commands to devices, to restart devices, and to control remotely these devices when connection is available. Actually, H Analytics removes the need of remote analytics resources for many tasks, and from another hand, there is much less need of internet connected computer. That means we have often options to work offline and to provide some analytics offline for our edge solutions. Additionally, design of edge solutions is simplified and the price for implementation and maintenance usually is lower. Of course, it depends on specific case and we can consider it case by case, but in general, long term, for most of solutions, edge analytics decrease the total price of solution, including implementation plus maintenance cost. One of the best advantages using Edge Analytics is that usually analytics can be dynamically uh, relocated from on-site edge computing to the cloud. So usually edge computer make decisions for different tasks and data processing where these tasks need to be implemented on the edge or on the cloud. For most of solutions, we can make dynamically change of the balance between data processing on the edge and on the cloud. We started to talk about edge analytics, but what is exactly IoT edge? Because we are talking also about IoT context. And for IoT Edge, we can say that it is a specific format of Edge Analytics focus for IoT solutions where we can run workloads on the edge. We have many advantages like reducing the bandwidth needed for IoT solutions to transfer data because for most of solutions, big amount of data is not needed long-term on the cloud. We need some data which is needed for long-term overall analysis, but huge amount of data can be processed, analyzed on-site, and it is not needed to store this data on the cloud, and in this case, of course, there is no need to transport this huge amount of data to the cloud. Edge solutions can clean and aggregate data locally and to send to the cloud only insights which are needed for long-term analysis. To summarize, IoT Edge is a specific edge analytics system that uses edge analysis for Internet of Things. Benefits are related to easier management of data and reducing the cost. We have higher reliability of the solution and management offline of many cases which we have in IoT solutions. We have better security, we have better privacy, and we can have availability of third-party modules for such solutions, so we can have edge solutions for IoT also extensible. We have several groups of features in IoT Edge solutions. From one side, we have complex event processing, which is pretty typical for modern IoT solutions. We have usage of machine learning and AI models. We have different applications which can be integrated to these solutions. We have very good improved offline support, and we have data management with balance, how to manage data on the edge and on the cloud. Next important question is when to use IoT Edge, in what kind of situations we can use IoT Edge taking the best advantages. Despite that, we can say that IoT Edge can be used in almost all real life cases. There are several important cases where the advantage of IoT Edge is very high. One of these cases is when we need near to real-time response for some local changes. For example, managing the production line and fraud detection. You need to have pretty fast response based on input data, and this analytics is much better to be done on the edge. Additionally, when it is needed to deploy and manage containers to edge devices, really it is some case where IoT Edge takes a lot of advantages. Usage of containers is already technological standard, so it is a powerful approach where we can simplify and unify management of many devices, especially when you are using containers for your device applications. It is much simpler and easier to take advantage from IoT Edge. We can say additionally that security using IoT Edge is much higher because we have edge devices with computing capabilities. Usually, devices are the weakest part of IoT solutions. So if we have computing capabilities on the edge, we definitely have also better security capabilities. Implementation of operations offline is another very important feature. So in such kind of situations when it is not sure if you are able to have always internet connection, definitely it is recommended to use IoT Edge. Also, if you have need to some specific AI analytics workload on the edge, you can get this advantage to use IoT Edge. That means to have Edge for IoT solutions and to get advantage that on these Edge devices you can also provide some AI workloads. Optimization of data cost because of lower transfer for uh, data from different locations to the cloud is another important feature, and of course privacy together with security is much easier to be managed using IoT Edge. Let's now see what is the benefit to use Azure IoT Edge based analytics system. If we are using Azure IoT Edge, we have common platform. We have no need of custom infrastructure for cloud services. We have components ready for use like IoT Gateway. In the current case for Azure IoT, it is Azure IoT Hub. We have different services, storage, web app, data processing services, and everything can be used uh, for implementation without additional effort to create these services. There is a common framework which is used for Azure IoT Edge and which can be used also to run AI analytics services, different kind of components on the edge. So it is much better to reuse this approach and to rely on this framework instead to create your own solution. From another hand, Azure coverage worldwide is pretty good, so you have no need to consider some fog computer with some intermediate services. You can use this very well distributed with data centers Azure coverage and to use Edge framework where you can reuse already existing available services plus to create your own models which can run on top of this framework. With Azure IoT Edge, we are trying to cover the top three trends in IoT and edge devices, increase security, analytics on the edge, and low power connectivity, the lowest one which is possible in the specific cases. There are many H analytics platforms provided from different vendors, but Microsoft Azure IoT Edge is probably the most complete one and easier to use, and that's the reason this session to be focused exactly on this platform. We have many different use cases for IoT Edge analytics, which can be considered also, of course, for Azure IoT Edge. We can use this for autonomous vehicles where it is needed quite often to have functionalities with pretty fast response and to consider also offline work when it is needed. Also, remote monitoring of assets in oil and gas, smart grids in smart energy industry, predictive maintenance for different business domains, in-hospital patient monitoring, radio networks for 5G networks, cloud gaming, content delivery, traffic management, smart home, security solutions, retail advertisement, video conferences, all these use cases actually can be very applicable with IoT Edge analytics. Let's now have an overview on Azure IoT Edge architecture. We will talk about Azure Edge and Azure IoT Edge, what is the common and why we talk about these two things together. We will talk about Iot H models, Iot H runtime, and how to monitor Iot H with Cloud Interface, which is actually Azure interface, web-based, which can be used to monitor and manage Iot H devices. IoT Edge and Azure IoT Edge and Azure IoT are tightly connected because Azure IoT Edge internally is integrated with Azure IoT solutions. It is possible almost out of the box to connect Azure IoT Edge solutions with IoT components in Microsoft Azure. So we have this flow where devices are using Azure IoT Edge. These devices can use it separately for each of these devices. This IoT Edge can be only on IoT gateway, which is used like field gateway for connection with cloud services. But in both cases, we have this integration between um, Azure IoT and devices powered from Azure IoT Edge framework. In Azure IoT Edge, we have three groups of components. We have IoT Edge models, which actually are represented as containerized applications. We have different functionalities which are implemented in this way, and these functionalities are encapsulated in containers like separate models. We have Iot H runtime, which is needed these components to run, and we have also cloud-based interface in Azure, which is used to monitor and manage IoT Edge devices. Probably the essential part of Azure IoT Edge is IoT Edge model. We have different IoT Edge models, as I already explained, and you can consider this like such kind of units of execution hosted in Docker-compatible containers. These components can communicate in between and also with models hosted in different devices. So the whole communication is provided from Rtx framework, but all functionalities which bring some business value are implemented like IoT Edge models. IoT Edge runtime environment provides infrastructure to have a functional IoT Edge models on devices and to deploy these models into devices. So whole base functionalities needed for containers to run are integrated in this Azure IoT Edge runtime, and communication between models also is implemented using this IoT Edge runtime. We have several responsibilities of Rtx runtime environment. One is related to maintaining of the security, which is very important for edge devices. Also, this framework ensures that IoT Edge models always running, so support monitoring and maintenance of IoT Edge models is implemented via IoT Edge framework. Reporting about model health also is integrated there. Communication between different models and devices is also part of this IoT Edge framework. This is the essential part which we actually are using from IoT Edge framework and rely to this solution. The third component is Iot H Cloud Interface. As I already explained, Iot H Cloud Interface is a web-based interface in Microsoft Azure, which is responsible to expose all needed functionalities to create, deploy, monitor, um, and manage these IoT edge devices. Actually, this cloud interface provides the whole tooling to manage your IoT edge solution. Iot H Hub is one of the most important parts of IoT Edge runtime. From one side, it is part of the runtime. From another side, it is implemented like IoT Edge model. But we can summarize that IoT Edge Hub acts as local proxy for Azure IoT Hub, exposing the same protocols like Azure IoT Hub and uh, supporting almost everything which we have also on the cloud. We can use MQTT and AMQP protocols. It is not possible to use HTTP. Yes, IoT Edge Hub is not full version of IoT Hub, but it runs locally and it reduces the bandwidth for your IoT Edge solutions. IoT Edge Hub offers connectivity and additional functionalities around configuring and control this connectivity not only for the connected devices but also to all other live devices which are connected to IoT gateway. When we create Azure IoT Edge solutions, it is good to be familiar with building blocks of Azure IoT because some services can be used also in both places on the cloud and on the edge. For other services, you can use it only on the cloud, but these services are important for the best setup for specific cases. So we have Azure IoT Hub, which also is the essential part of IoT solutions and Azure IoT solutions. It is the Microsoft gateway service for IoT solutions hosted in Azure. Essential component, very important with very high security and options for configuration and provisioning. We have event hubs, which are messaging services focused for high volume message spreading. We have Azure Stream Analytics. This service is focused on data streaming, stream processing. We can use it on the cloud and on the edge. Blob storage also can be used on the edge and on the cloud, and it is the main service used for storing of binary data. Cosmos DB is the main NoSQL database as a service, providing different data models like polyglot database. Time series insight are also very valuable as components when you have time series for which you need to make easy different kind of analysis. For real-time stream processing, we can use also Azure Databricks, Edge Insight, and different implementations of Hadoop. For serverless components, we are using Azure Functions, SQL Database as services database which provides SQL Server capabilities. We have Machine Learning Studio, where via web-based IDE we are able to build and deploy machine learning models, and of course Power BI like rich dashboard and visualization tool. Let's now consider Azure IoT Edge architecture in depth. Azure IoT Edge is designed on modular principle using edge modules based on containerized applications. These models are built on top of Mobi, which is open source framework that powers Docker. That means you have the main functionalities of Docker framework, but it is lighter, simplified version because you have no need of full Docker for your edge devices. We have very good capabilities to have device provisioning. Devices can be registered only during the initial onboarding process, and after that can be managed from the cloud. But we have all functionalities which Azure IoT offers for zero-touch device provisioning, also for edge devices. And of course, edge devices are considered as IoT devices that are capable to running additional services. This is the most important when we are talking about Azure IoT Edge and AI Edge because we can have fully functional edge solution with any kind of edge IoT edge functionalities and AI functionalities on top of the same platform. So we are using Azure IoT Edge framework to run models with different purpose. And this framework is very applicable also for Azure AI Edge solutions. Let's look at schematic representation of Azure IoT Edge. We have Azure IoT Edge Runtime, like the foundation of our framework. You have additionally IoT Edge Hub and IoT Edge Agent. We will talk about Agent additionally. This component is responsible for starting of models and ensuring that models are running. Both IoT Edge Hub and IoT Edge Agent are realized like models, but they are part of the runtime. We have different models with specific logic. These models can be offered from Microsoft, from third-party vendors. Some models are available as part of Azure IoT Edge framework. You can create own models and deploy it. We have devices powered by Azure IoT Edge framework, but also devices which are not edge devices but are connected to um, edge devices powered from IoT Edge framework have also benefits from the whole platform. Additionally, we have Azure IoT Control Panel in the cloud, which is responsible to monitor and maintain all these edge devices. In Azure IoT, we have several options how to configure and implement connection between backend and cloud gateway and devices. We can have direct connection. We have edge device which is connected to cloud gateway. It is possible to have a group of devices where field gateway, um, this edge device which establish connection with the backend actually communicates with cloud gateway using Azure IoT Edge framework and connection with other devices depending on how devices are implemented, powered by Azure IoT Edge framework. If they are edge devices or not, we can have different options for design and configuration. It is possible if devices are not modern or if devices do not support protocols offered from Azure IoT Hub to use custom cloud gateway or to have a service which translate um, protocols. It is needed in some specific cases. It is possible to use also additional VPN connection for some specific security cases, despite that Azure IoT is very safe. If you are using custom cloud gateway, in such situations, this custom cloud gateway can be not designed in the same way like Azure IoT Hub with service assisted communication pattern, and it is possible to need to ensure it additionally with some technologies like VPN connection. All communication between modules is based on Azure IoT H Runtime. The idea is modules to be not responsible for direct communication in between in this way to simplify and make more general communication between different models. This communication is facilitated by IoT H Hub. IoT H Agent is a specific model, again part of the runtime, which is dedicated to instantiating models, ensuring that these models continue to work properly. And H agent reports the status of models to IoT Hub. We need to have a configuration of IoT H agent using set of properties. IoT H models actually are represented as model image, which packaging whole software and settings which we need for model definition. We are using these models to have different pieces of functional code with isolated logic and to have many building blocks to build the overall IoT Edge solution. To be possible to manage IoT Edge models, each model has specific identity, which is piece of information stored in IoT Hub, which is used for managing of this model. Similarly to device configuration for Azure IoT, where we have device twins, here for models, we have model twin. Model twin is JSON document with pretty similar logic, group of properties which are desired and group of properties which represent the current configuration. The idea is to be possible without direct calls between models and backend services to update and reconfigure models. Device twin and model twin actually work on the same principle, just model twin is focused on configuration and properties for specific Azure IoT Edge model. One of the best advantages using IoT Edge models is that you can prepare different models which represent specific requirements for different regions and to deploy for different regions or for specific tenants, organizations, models with different configuration. And in this way, to simplify the overall solution, instead to have very complex conditional logic on the same model for overall regions and organizations, you can have different models prepared for specific regions and organization, and to deploy these models depending on where and for which organization you need to provide some functionality. Let's now consider best practices implementing solutions with Azure IoT Edge. We already discussed about cases when IoT Edge has advantage in general, and here for Azure IoT Edge we can consider additionally protocol translation, simplified development process because we have already platform for this. We can reuse all these components and we can use different analytics services out of the box or custom on top of Azure IoT Edge platform. So in different cases where you need edge computing, IoT Edge is very applicable, especially when backend is powered by Microsoft Azure. One of the best advantages is that we have one common platform. It is possible to implement models as containerized applications and to deploy different devices. So management and maintenance are very easy. Deployment is simplified, and we can reuse many functionalities from the base framework. We need to consider some good practices about edge devices, about device registration and overall provisioning process, some good practices about model development, deployment, upgrades of software, and of course, security. When we are talking about AI on the edge, one of the great options to have almost out of the box some functionalities is to use cognitive services on the edge. For cognitive services, usually we have solutions where cloud services work together with deployed on the edge models. The workflow requires to create cognitive service on the cloud, to configure Azure Cognitive Services API, and to get API key for the endpoint. And when you have this, you can deploy the model for these functionalities also to the edge device. Management of models related to IoT Edge platform, not only for AI in general, is done using web interface in Microsoft Azure Management Portal in the context of settings for Azure IoT Hub. It is interesting to clarify how Azure Machine Learning is working on IoT Edge as model. The workflow of creation of Azure Machine Learning model requires first to create this model. That means you need to have a model which you will train. You will create Azure Machine Learning model. You will push this model as container to Azure Container Registry, and you will deploy Azure Machine Learning model to your edge devices. When we have Azure Machine Learning models, usually we can have many times redeployment of these models because based on new data, we can train our models additionally to increase the accuracy when we have need to analyze specific cases and to find the best solutions. One of the most important parts of RTH is to implement properly security and privacy on RTH. And there we have several cases. We need to know about different type of attacks which can be done. We need to protect Azure Analytics application. We need to monitor and audit H Analytics applications. About the first part where you need to have the knowledge about different types of attacks, it is something which is not related to Azure IoT Edge framework. So you need to have good understanding about possible vulnerabilities. But regarding to the last two points, how to protect Edge Analytics applications and how to monitor and audit Edge Analytics applications, Azure IoT Edge offers quite powerful toolset. You will be able to use functionalities related to Edge Hub from one side because it is implemented based on the good secure practices. From another hand, if you use Azure IoT Edge Runtime, all configurations and communications are implemented via this runtime on a high-level security approach. Let's now talk about Iot H deployment. About Iot H deployment, we have two different approaches, manual and automatic. Manual means that using um, Azure IoT components and especially IoT Hub and IoT Hub device provisioning service, you can have deployments and provisioning of devices. You can do this per device, but you can have automatic deployments, grouping device based on specific tasks. You can add edge devices to IoT Hub in several different ways using Azure Management Portal, using Azure CLI. It is possible, of course, to have also programmatically custom implementation using IoT Hub SDK. We have pretty similar approach also for registering the devices using Azure IoT Hub Device Provisioning Service. You have just specific set of options where you need to notify that this device is edge device. The edge devices are visible from the cloud interface managing devices, and you can manage it in a similar way like other devices, but of course having additional options to deploy models and to configure more specific options, especially for edge devices. One interesting case is how to design deployment. From one side, it is possible to have phase deployment where for each new update, you have redeployment and or reconfiguration for all layers of your application. And you can do this again manually or automated. And you can have layer deployment where you can have different layers and to update these layers independently. In this way, you have more flexibility from one side, but of course, dependencies between layers regarding to usage of specific models and libraries need to be considered very well. When we have layered approach, properties which we are using for configuration actually can be added for specific layers and you can have the final configuration including also layered property. It is good to have deployment checklist where to have what is needed for your device configuration, deployment, container management, networking, and solution management. If you have all these steps and clear understanding what is needed, actually your deployment will be designed in a good way and you will be able to manage it and to consider how to change the overall process in different cases. And now it is time for demos. For this demo, I already created a virtual machine where is installed Iot H framework. We have on this virtual machine open SSH and public IP address, which we will use for this presentation. And I already installed the latest version of Iot H because we have limited timeline and will demonstrate actually how it's possible to configure our IoT Hub with additional settings for edge devices. We already have IoT Hub provisioned and we already have also two provisioned IoT Edge devices. To be possible, to add modules, you need to select device, and you can use set modules to add, remove, and update existing models. We already created one model which is implementing sentiment analysis of cognitive services, but I will give additional insights how to do that. To be possible to have cognitive services on the edge, you first need to create cognitive services instance which will be available as service in the cloud. So we need to create this instance. We need to choose subscription, resource group, location, name, and pricing tier. I already have created one resource, so I will go back to my cognitive services created resource, and here you need to get endpoint and one of the keys, because we will need to use these keys in our edge device. When we have our cognitive services in the cloud, we need to have also edge model. It is possible to create this edge model in the following way. We will try to create this resource. And you see here sentiment analysis model. Of course, there are several different modules for different functionalities which we have in cognitive services, but for these functionalities, we have also separate modules for the edge. When we create this resource, we need to choose subscription, we need to choose device, and IoT hub, which will be used. When module is installed, we can see this module available in our device. With set modules, it is possible to make some changes. In environment variables, you need to choose endpoint and key. And when you have all these settings, it is possible to update your model. We can try how model is working using Swagger, and if we open the address of our virtual machine for testing, this virtualized device with port 5000 Swagger, we can see options for different API endpoints. We can try to execute specific endpoint with sample data and to see results. You can see a response JSON document with sentiment analysis about different worlds in the phrases. So that's the most important. We can have the same with other API endpoints. Thank you for watching, and if you have any questions, feel free to contact me via social networks or email. I will be glad to discuss about cognitive services, ML, and any kind of AI components on IoT Edge.